Welcome to Learning Intention 3, Data Visualization and Theoretical Probability. In this video, we're going to have a look at doing two different things today. So the first one we're going to have a look at is representing data using three different types of methods. The first one being lists, grids, and tree diagrams. The second part of the video, we're going to delve into theoretical probability. And in theoretical probability, we're going to learn the skills to express the probability of an event in the form of either a fraction or a percentage. So today, some of this is likely going to be revision for you guys, but I think it's a good idea to have a refresher on the topic because it is such an important skill to have in mathematics. I think it's worth going back and just making sure that everyone is up to speed and able to do this stuff. Now, jumping straight into it, the first data visualization we're going to look at today is lists. So a list is simply notation that we've already used in set theory. So it's what we were learning in Learning Intention 2. Now, consider flipping a coin. If we were going to list all the outcomes of flipping a coin 6 times, we could say that C, so this set C represents the results of flipping a coin 6 times, and of those 6 flips that landed on heads, tails, tails, heads, tails, and heads. Now, one extra piece of information that I'm going to put into this little section is consider the dimensionality of the coin flip. So all of these events happened in a sequential manner. So we could say that this data here is one-dimensional. So nothing too special about it. So it's one-dimensional data. Now, what if we're doing an experiment and there's more than one dimension to it? So in which case we could use something called a grid. So consider you ran 2 independent experiments in parallel and you wanted to list the data from those 2 experiments. So we could choose again the flipping of a coin and perhaps the spinning of a spinner. So we could use a grid to illustrate the outcomes of flipping the coin and spinning the spinner. So notice the coin could land on heads and tails, and when you're spinning it, it could spin and land on, say, A, B, or C. So the way in which we can represent it is the grid here. So notice on the vertical axis, it is the result of the spinner, and on the horizontal axis, you've got the result of a coin. So say if you landed the coin on heads and the spinner landed on A, then it would occupy this section of the grid just here. Similarly, if the coin landed on tails and the spinner landed on B, then it would occupy this part of the grid here. So notice this data is 2-dimensional. Now, the final method of visualizing data that we're going to look at today is using tree diagrams. So, a tree diagram could be something like, tossing a coin 3 times. So again, you could use the grid or an array, but a tree diagram could be possibly more intuitive. So if I draw an example of it, so let me get my pen. We'll go a nice blue pen. You could say coin flip, and then it can be broken down into heads or tails. And we're going to flip it again, and on the next flip, you could have a result of heads and tails. And then flipping for the 3rd time, you'd have a result of heads tails. I'll get rid of this here. Heads, tails, heads, tails, and heads, and tails. So looking at the possibilities that could happen, on a single coin flip, it could land on heads or tails. Considering it landed on heads, or supposing it landed on heads, it could land on heads or tails again. So considering heads, heads, on the final one it could be heads or tails. So all of the results you could have following the tree diagram. So in the first instance, you could have something like heads, heads, heads. Then on the second one, the outcome could be heads, heads, tails. On the third one, you could have heads, tails, and heads. And it could go on or go on forever. So you could have 1, 2, 3, 4, 5, 6, 7, 8 different types of outcomes, and a tree diagram is just another intuitive way of representing it. Now the tree diagram itself, it doesn't always have to have 2 options. It could have 3 options. So consider a football game. Whoops. You could have win, draw, draw, and loss. And if you wanted to go on, you could keep branching it down. So you could win, win, or win, lose, or win, draw, win, lose. So a tree diagram is really great in showing multi-stage experiments and all the different likely outcomes that could occur. So it's a lot more intuitive to look at the tree diagram than to look at a number of different sets of data. So, whoops, already done that. So in summary, what we did was we looked at lists. So P equals tails and heads. So like a coin flip, expressing data like that. We looked at a grid. So in this case, we had coin flip down here and a spinner over here. So A, B, and C. And then you'd have a simple grid as such. And each little point on the grid represents the combination. So spinner lands on A and coin flip lands on B. So you'd be somewhere like that. And finally, we had the tree diagram. So use a green pen for this one. So let's say coin flip. We had heads and tails. And remembering that the grids and the tree diagrams were really great for representing 2-dimensional data or multi-step experiments. So lists are great for single-dimensional, grids are great for 2-dimensional, and trees are great for 2-dimensional and multi-experiment.